Now that we've covered molecules and atoms, in the next sections we're going to investigate how chemicals react. So in this video we're going to talk about chemical equations and chemical reactions. So a chemical reaction is a chemical change where one substance is converted into another substance. And when this occurs, chemical bonds in the starting materials are broken and new bonds are formed, generating a new substance or substances. A chemical equation is a symbolic representation of a chemical reaction. And in these chemical equations, we typically represent the starting materials on the left-hand side, followed by an arrow, then the ending materials over on the right-hand side. So the way we chemists represent our starting materials, we call these reactants, then we draw an arrow, and after the arrow, we call the ending materials products. The left-hand side is the reactant, the right-hand side is the products. For example, we have the reactants hydrogen plus oxygen, and the products of the reaction are two water molecules. Something that I want to bring up here is notice how I called H2 hydrogen, not dihydrogen, and O2 is oxygen, not dioxygen. Well, there are a few diatomic molecules that naturally occur, and these are hydrogen, H2, nitrogen, N2, oxygen, O2, fluorine, F2, bromine, Br2, and iodine, I2. And we just call these molecules by their element name. So back to talking about chemical equations. So my equation reads 2 molecules of H2 reacts with 1 molecule of oxygen, and that produces 2 molecules of water. Notice that I have the same number of hydrogen atoms on the reactant side of the equation as the product side. So 4 hydrogen atoms on both the product side and the reactant side. And oxygen, we have the same number of oxygen atoms on the reactant and the product side of the equation. Okay, so this reaction is what we call balanced. So the number of atoms of each type are the same at the start and at the end of the reaction. So equations are not always going to be given to you balanced like this. And you're going to learn how to balance reactions. And we do this by using coefficients. See the number 2 in front of the hydrogen and the 2 in front of the water molecule? Well, this number tells us how many molecules of that particular type of compound are present. So for this one, we have 2 molecules of hydrogen reacting with 1 molecule of oxygen to form 2 molecules of water. These numbers in front of the chemical formulas are called stoichiometric coefficients. And this is a theme we have for the first half of this chapter. You may notice these letters in parentheses next to each formula in some chemical equations. Well, these letters in parentheses tell us the state of matter, whether the material is a solid, liquid, or aqueous solution. We symbolize G for a gas, L for a liquid, S is for solid, and aqueous is symbolized as AQ. And aqueous just means that the sample is dissolved in water. So one last thing before we start balancing equations. Why do we use coefficients instead of changing the subscripts to balance the chemical equations? Well, if we did that, we would be changing the formula of the compound. So for example, let's say we want to combine hydrogen and oxygen to make water, H2O. In the first equation here, I use a coefficient to balance the number of hydrogens and oxygens on both sides of the equation. So I have 4 hydrogens on both sides and 2 oxygens on both sides of the equation. So in our second equation, I changed the number of oxygens in the formula of water because we needed an additional oxygen on the product side. By changing the subscript, this gives us a different formula, H2O2. Now this equation is balanced. However, this is no longer water, it's hydrogen peroxide, and we can't do that. We can't change the formula of our compound. We can only change the amount of the element or chemical imbalancing. We can't change the formula of the compound because changing the formula of the compound changes the identity of that substance and its chemical properties. So we can't change the identity of a compound when balancing the equation. We can only change how much. We've now discussed what a chemical reaction is, and now let's learn to balance chemical reactions. In the next couple of slides here, I'm going to give you some tips on balancing reactions. Now, these are not rules, but guidelines to help you. So we have the combustion of propane, which is a reaction of C3H8 plus oxygen. And this produces carbon dioxide and water. Right now, this equation is not balanced. We have 3 carbons on the reactant side and only 1 carbon on the product side. The hydrogens are not balanced either. We have 8 hydrogens on the reactant side and 2 hydrogens on the product side. And the oxygens are not balanced either. We have 2 oxygens on the reactant side and 3 oxygens on the product side. Where do I get 3? So I have 2 oxygens from the carbon dioxide and the 1 oxygen from water. So 2 plus 1 equals 3. So the first thing you want to do when you're balancing reactions is to balance all the elements that are not hydrogen or oxygen first. So for example here, we see that we have 3 carbons on the reactant side and we need 3 carbons on the product side. So we can change this by placing a 3 in front of the carbon dioxide. So this gives us 3 carbons on the product side and the reactant side, but the hydrogen oxygens are not balanced. In putting the 3 in front of the carbon dioxide, we now have 6 oxygen atoms, plus the 1 oxygen atom from the water gives us 7 oxygen atoms on the product side. Next, let's try to balance the hydrogens. So we have 8 hydrogens on the reactant side, so we need to change the coefficient on the water on the product side to give us more hydrogens. If we put a 4 in front of the water, that balances the number of hydrogens to 8 on each side. Now this also changes the number of oxygen atoms as well. We still have the 6 oxygens from carbon dioxide and now 4 oxygens from the water. So we have to add 6 plus 4 to give us 10 oxygen atoms on the product side. So what we see here is oxygen is still not balanced. So what we do next is put a 5 in front of the O2, and that gives us 10 oxygen atoms on the reactant side. And so we have 10 oxygen atoms on the product side. So now we are balanced. We have 3 carbons on each side, 8 hydrogens on each side, and 10 oxygens on both sides. So the second tip is that we want to balance polyatomic ions as a single entity if they appear on both sides of the equation. So if you have the phosphate ion, PO4, you want to deal with that as a single entity because the phosphorus and the oxygen are going to stick together. They're not going to be separated. So for example, if we have calcium chloride, CaCl2 reacts with phosphoric acid, H3PO4, this produces calcium phosphate, Ca3PO4, 2, and hydrochloric acid, HCl. So if we look here, we can see that 1 calcium atom on the reactant side, 3 calciums on the product side. We have 2 chlorines on the reactant side and 1 chlorine on the product side. 3 hydrogens on the reactant side and 1 hydrogen on the product side, 1 phosphate ion on the reactant side, and 2 phosphate ions on the product side. This equation is definitely not balanced. So let's put a 3 in front of the calcium chloride, and now that gives us 3 calcium on the reactant side to match the 3 calcium on the product side. Now this also changes the number of chlorine atoms on the reactant side. Since we have 2 chlorine atoms for every 1 molecule of calcium chloride, we have to multiply the coefficient by the subscript. So here we have 3 times 2 gives us 6 chlorine atoms. Let's look at the chlorines. We have 6 chlorines on the reactant side and only 1 chlorine on the product side. So let's put a 6 in front of the hydrochloric acid, and that balances our chlorines. This coefficient also changes the number of hydrogens on the product side. So now we have 6 hydrogens on the product side. From the previous slide, we want to balance the hydrogens and oxygens last. So we're going to skip over the hydrogen balancing for now. Next, we want to balance the phosphate ion as a single entity. Now we have 1 PO4 on the reactant side and 2 PO4 on the product side. So if we put a 2 in front of the H3PO4 on the reactant side, that gives us balanced phosphate ions, where there are 2 phosphates on both sides of the equation. Now, once we do this, our hydrogens also become balanced. We now have 6 hydrogens on the reactant side because we need to multiply the coefficient 2 by the number of hydrogens in the formula. So that's 2 times 3 equals 6. So remember tip 1, try to balance the oxygen and hydrogen atoms last. That's really going to help you. And our second tip is to balance the polyatomic ions as a single entity. And our last tip here is if there are an even number of atoms on one side of an equation and an odd number of atoms on the other side, begin by multiplying the odd numbered side with a 2. For example, nitrogen reacts with hydrogen to form ammonia, NH3. We have an odd number of hydrogen and nitrogen on the product side. So we'll put a 2 in front of the ammonia. That gives us 2 nitrogens on both sides of the equation and 6 hydrogens on. Now, if we put a 3 in front of the hydrogen on the reactant side, that gives us 6 hydrogens on the product side and the reactant side. And one last note, always check your work. Make sure there are the same number of each type of atom on both sides of the equation before you move on. And these tips are not necessarily the golden rule of balancing chemical equations. They're more meant to help you. If you happen to find more tips and tricks in balancing chemical equations, certainly please share these with your classmates.